The paper that I will present is co-authored by the people that you see in the screen. And I think it fits very well with Galina's presentation because the methodology you'll see is completely different, but it still deals with physical asset stranding. So we're not looking at the two most common types of assets at risk of stranding, that is fossil reserves and financial assets, but rather we're looking at every physical asset that is used to produce goods and services. In our case, asset stranding, we mean asset stranding looking at the reduction in capacity utilization, so not really at the price, at the value of capital stocks. There's not much of a liquid market of built infrastructure, but rather at the extent at which it is utilized. And what we're interested in is to have a systemic perspective. So that's the core of the paper. So we are interested in, of course, looking at the mining sector, which is the origin of the stranding, and look at how the extent at which the infrastructure and the capital stock in the mining sector becomes stranded due to decarbonization. But then we also want to look at the sectors that use fossil fuels as intermediate inputs, and then the sectors that use those sectors, intermediate inputs, and so on towards the downstream service sectors. This is just a pyramid representation that you'll see fits our methodology, but the reality is that you have, that this is a network. It's a complex web of exchanges of intermediate inputs from one sector to another, and the network is dense. Everybody is exchanging with everyone else. So what we're trying to understand is the extent at which, to which decarbonization would lead to stranding of physical assets in the economy as a whole. And in our mind, this is complementary to the work being developed on financial networks, right? Because, for instance, if you look at the Battiston paper on climate stress testing, what happens there is that you have a shock from the fossil fuel sector or the utility sector, and then this propagates within the financial network. And the point that we're trying to make is that really the shock to the financial network can come from anywhere, right? It doesn't have to be fossil fuel sector, it can be chemicals, it can be metals, it can be transport, it can be, I don't know exactly where. The point is trying to understand it. And so we would like to develop a production network counterpart to the financial network analysis of stranding. And that's what we do. The literature that we're aware of is not that developed. There is a strand of literature looking at committed emissions. So you look at capital stocks, you calculate the amount of emissions that would be emitted during the course of the lifetime. And usually the results there is that the emissions would not be compatible with a 2-degree objective. So it's either going beyond 2 degrees or decommissioning part of the capital stock. But again, this is usually sector specific, while our research curiosity is really on the system as a whole. So what we do is we use another couple of methodological approaches. Essentially, we take input-output techniques. We don't use the usual Leontief approach. We use another approach which is called Gauche. I'm happy to go in details if you want it during the Q&A. And then we we create new matrices. I'll show them to you now. And then we treat them as networks. And we essentially replicate this literature that is being developed in economics on production networks, except in our case, we're not looking at production tables, but we're looking at these matrices that we create of stranding assets, asset stranding multipliers. So what we do is 3 things. We create these national matrices of asset stranding multipliers that tells us essentially for each sector in the economy how exposed their capital stock is to a reduction in inputs from other sectors. And I'll show it to you very quickly because this is not really the point of the paper, but very rich information comes out of it. For the purpose of the paper, the main thing here is that it shows that mining, which is where fossil fuels are produced or imported, is among the sectors that can create most stranding. It's not the only one. There are other sectors that can create stranding, physical stranding in the economy. Mining is one of the most relevant ones. So then we look at mining and we create new networks, and we basically want to understand how the stranding risk propagates within the production network, which sectors are affected and through which channels. And finally, we provide an estimate of, it's a ballpark figure of the total capital stock at risk of stranding. We wanted to give a monetary value to the capital at risk. And that's what we do. We apply this methodology. So this is a mix of a methodology paper and an empirical paper, because we put forward this methodology that we think can be useful, and then we apply it to these 10 European countries. We use Eurostat data from 2010. Let me already, so this is a stylized representation of the input-output tables, which I'm pretty sure you're familiar with. The gray matrix is our main core of analysis, the inter-industry matrix. So all the exchanges of intermediate inputs between different firms in different sectors. And here, of course, it's stylized. You have a sector A and sector B. In our data, we use NACE classification system. So we have, at the minimum, these sectors. This is level 1 NACE. We usually have level 2 NACE, meaning we have 64 sectors, but it really depends on the granularity that the statistical office, the National Statistical Office offers. So for Germany, for instance, this is the level of disaggregation that we have. I will remind you what all these letters mean, but the main point here is to remember B. B is the mining sector, and this is at the center of our analysis. So what we do, as I said, is we take these input-output matrices, we manipulate them, we combine them with capital stock data, and we obtain these matrices. So it's like an input-output table, so all the sectors as suppliers, all the sectors as recipients of intermediate inputs, except in our case, it's a matrix of multipliers, of asset stranding multipliers. So each entry in this matrix means one reduction of input provided by the column sector creates capital asset stranding of X, of the value of the matrix in the row sector. So for instance, you have one less input of fossil fuels. What is this stranding in the information and communication sector? And this is both, it takes into account both direct effects and indirect effects through the whole production network. And so we obtain, and then we treat these as matrices as networks, and we obtain networks like this. So very quickly, this is for Germany 2010. The important thing here is to see here, if you, oh, there's no pointer. Anyway, you see all the sectors, and you see that sector B, the outward vectors here mean outward stranding links. And you can see that, for instance, B has relevant stranding links to sector D, which is electricity, and sector C, which is manufacturing, and sector O, which is public administration. You also observe that other sectors have very large outward links, meaning, for instance, if you see up there M and N, this is technical activities, scientific activities, administrative activities. These are likely to create large stranding in the economy as well. But this is, let's say, for another paper, okay? This is interesting to us because it tells us something about the structure of the economic system. But in our case, the important thing for us is that essentially B appears to be one of the most relevant sectors in terms of asset stranding multipliers in all countries. It's at the first position for France and Italy, second place for Germany, and anyway, it's in the top 10 for all European countries. So for all economic systems, this is likely to be an issue if mining inputs decrease, as they should if we want to decarbonize and in absence of CCS and so on. Okay, so this is the first part. This is, let's say, our justification. And then we start looking then at the mining sector. And what we do is we create new networks. Let me show them to you and I'll explain them looking at them. You see, we have B at the very top of the cascade because we choose to have it at the center of our shock. Let's say this is the origin of our shock. And then we look at how it propagates within the system. As I said, these are dense networks, so B will create stranding everywhere. But some of the links are not really relevant, so we adopt a Q threshold, so we take only 5%, or the most relevant 5% stranding links. And we create the first layer of assets, of sectors. These are the most affected directly from B. And then we repeat the procedure for the sectors in the first layer. We create a second layer of sectors affected by the first layer sectors, and then so on, so on, so on, until there are no more sectors. Mind that not all sectors appear here, only the ones part of this selected group of sectors that are the most affected by the cascades, okay? So you have other sectors that don't appear because they are affected, but to a small amount. And yeah, we obtain this type of figures for all countries. So this is the United Kingdom, for instance. This is Sweden. This is Austria. This is just for representation purposes to show you the type of analysis that we provide. And what we do then is we study these networks. We try to identify common patterns, and then we analyze the peculiarities in the different regions. Let me give you a sense of the common patterns, so things that we observe almost everywhere. The most affected sectors by decarbonization appear to be, probably unsurprisingly, the most affected one is D, electricity and gas. This is the most affected sector in all countries in our sample except Belgium, where transportation is the most affected one. So you see, for instance, the thickness of the edge of the network gives a sense of how large is the stranding. So those numbers mean that one unitary reduction of inputs from the mining sector will create 0.7 monetary units of capital stock stranding in the electricity sector in Austria. Other sectors that appear in the first layer quite often are some manufacturing sector, and in particular C19, which is coke and refined petroleum products, and C24, which is basic metals. And finally, the other sectors that appear quite often, not here, but for instance, in the UK, you see H49, this is land transportation. Transportation sectors appear quite often in this first layer of most affected sectors. And then we observe certain typical cascades, right? So from B, you affect these first layer sectors, and then this kind of trickles down to other sectors. And the force of the stranding becomes lower and lower, but still relevant enough to appear in the network. And for instance, from the D sector, from the electricity sector, we often observe stranding links to E36, which is water and water supply and treatment, and O, public administration. So this we observe quite often. We observe from C24, from basic metals, we observe a stranding on C25, which is fabricated metal products, C29, which is motor vehicles. That happens quite often. The clustering of H sectors is also very typical. So, for instance, you see here it goes from H49, which is land transport, to H52, which is warehousing, to air transportation, which is H51. So once a transportation sector is affected by stranding, then it affects all the rest of transportation sectors. What else? From C19 also, we typically observe from coke and refined petroleum products relevant stranding effects to C20, which is chemicals. Okay, so anyway, you get the point. We observe we create these networks and then we study them, and the paper at the moment is still in a working paper form. We essentially look at these common patterns, and we would like also to then compare countries, because of course you see how Sweden, for instance, is very different from Austria, which is different from the UK. That depends on the structure of the economic system. The last thing that we do, this is everything that I said, the last thing that we do is we try to give a value. This needs to be taken with a pinch of salt, because what I've shown you until now, it concerns small shocks, and the methodology is quite solid with small shocks. In the case of, now we want to have an estimate of the total capital at risk of stranding from decarbonisation. So it's a large shock, and the methodology is less solid because, of course, you could imagine some changes, some reaction from firms that diversify their inputs. We also have an assumption of perfect substitution among intermediate inputs. So there are some caveats here. But we still wanted to have like an idea of the capital stock at risk of stranding. That doesn't mean that it will become stranded. So we take into account both the mining sector and everyone else that uses fossil fuels as inputs. They're calculated in different ways, of course. We complement Eurostat with another database, and these are the results. So you see, you have the 10 countries, you have the total capital in monetary values, this is million euros at risk of stranding, and the percentage gives you an idea of the percentage of the total capital stock at risk of stranding. And then you have also sectoral values. And in this case, the percentage means the total capital of that sector that is at risk of stranding. You see that there are quite strong differences across countries. So places like Austria, Belgium, they're affected, but below 1% of total capital stock is at risk of stranding, while other countries, including the UK is around 3.6. Slovakia is an outlier with more than 8%. But then you also have different sectoral values for the different countries. Again, most of the countries have electricity and gas as the most relevant sector to look at in terms of asset stranding, and Dirk is clearly telling me with his face that I should stop, so I will. If you want, the working paper is here, and the code is also available if you're into R.
Please do still the conclusions, that's nice.
Okay, so yeah, shall I go through it? Yeah, as I was saying, the paper introduces a new methodology that we think might be relevant to analyze, to complement the financial network stranding literature with a production network stranding literature, and we show that it gives meaningful and interesting results for this selection of countries. So we have a number of things that we would like to do. But the most important one is probably the last two. So we want to look at how this connects then to the financial effects and include dynamic effects, because at the moment this is a typical input-output analysis which is static. Thank you. So I'm very looking forward to your comments.